So good afternoon everybody. Myself ACHARYA VISHVENDRA. This is NCERT line to line discussion chapter 14 semiconductor electronics. So let's start with that. I was discussing question number I think 181. So it behind a donor, leaves behind a donor. One is correct. Next, in the above question, this ionized donor has. So obviously it will be having positive charge. First is correct. Next is in the above question, the ionized donor is immobile because it is bounded, obviously bounded to the surrounding atoms. First is correct. Next is as the electron continue to diffuse from n side to p side. So because of this, a layer of positive charge on n side is developed. So first is correct over here. Next is when a hole diffuse from p side to n side, it leaves behind an ionized. So when holes diffuse from p side to n side, it leaves behind an ionized. So obviously it is it leaves behind obviously an acceptor. In the above question, charge on acceptor is obviously negative, so it is having a negative charge. Next is as the holes continues to diffuse, a layer of obviously negative charge develops on the p side. Next is the space. The space charge region on either side of the junction is called. It is the depletion region. Next is direction of electrons drift is from in a PN junction. So direction of electron drift is opposite to the diffusion. Diffusion is from N to P, so drift will be from P to N. First is correct over here. Next is direction of hole drift in a PN junction is from. So holes move from diffuse from P to N, so drift will be from N to P side. First is correct over here. Next is depletion region is so called because obviously because it is depleted of the free charge. There are no free charge carriers, so it has got very high resistance. So first is correct. Next is thickness of the depletion layer is of the order of. So the thickness is 1/10 of a micrometer. So first is correct over here. Next is direction of electric field in PN junction is from. So obviously it's from N side to the P side. As suppose this is your P, this is your N. So here we have negative charge, here we have positive charge. So the electric field will be from N side to P side. Next is due to electric field near PN junction, electrons move from obviously force on electron will be opposite to the field, so they will move from P to N. First is correct. And holes will be moving from N to P. Next is motion of charge carriers due to electric field near PN junction is called, it's called the drift. Next is drift current. Next question is about the direction of the drift current. So drift current is opposite direction of diffusion. Second is correct. Next is when PN junction formation starts, initially obviously diffusion current is more. First is correct. Next is in a PN junction formation, as diffusion process continues, space charge region on either side of the junction, obviously it extends initially. Next is in a p-n junction formation, as the diffusion process continues, the electric field strength in the p-n junction. Obviously, diffusion increases, that means the depletion layer will extend as more charge-free regions will be created. So that will increase the strength of the electric field. So when a p-n junction is forward biased, then obviously, yes, in equilibrium, both are equal. So first is correct over here. Next is under equilibrium, there is no net current. That is correct. Next is polarity of barrier voltage is to yes, barrier voltage is having a polarity so that it opposes the diffusion. So it's to oppose the further flow of charge carriers. And second is correct over here. Next is a p-n junction under equilibrium is represented as. So on the p side there will be negative. Yeah, this is corrected by the first diagram. So one is correct over here. Next is barrier voltage under no bias is represented by so obviously, as electric field is from N to P, so N side will be at higher potential as compared to P. So first is correct over here. Next is in a p-n junction, P region is at positive, obviously first is correct. Next, barrier potential is called so because obviously it prevents movement of electrons from N to P region. It opposes the diffusion current, so first is correct over here. Next is, can we take one slab of P type and join it with N type? No, it's not possible. Next is in the above question, p-n junction is not formed because any slab will have continuous contact is not possible, so both are correct over here. Next is crystal spacing in interatomic crystals is of the order of, so the crystal spacing is of the order of 2 to 3 angstroms, so one is correct. Next is a semiconductor diode can be represented as, so we have it can be represented by both as near P side we have negative charges and then N side we have positive charge. So third is correct. Next is symbol of p-n junction is, so it's the first symbol that we have. Next is in the above question arrow represents, so it represents conventional direction of flow of current, first is correct. Next is if an external voltage is given, P is connected to the positive and N to negative, then it is called obviously the forward bias. In a p-n junction, voltage drop is maximum across, obviously across the depletion region, third is correct. Next is in the depletion layer, voltage drop is maximum because it has very high resistance. So as compared to P and N side, it has got very high resistance, so third is correct over here. Next is during forward biasing, direction of electric field due to external voltages, obviously it is anti-parallel to the junction electric field, which reduces the barrier voltage and allows free movement of charge carriers. Next is during forward biasing, width of depletion layer obviously decreases, so first is correct over here. In the above question, if external voltage is V, built-in voltage is V0, the effective barrier height is, so it decreases, so effective is V minus V0, or maybe so it is V0 minus V. Next is in the above question, if applied voltage is small, then current will be, obviously current will be small. Next is in the above question, if applied voltage is